right, so at this point, we are going to describe location using three terms: distance, position, and displacement. And having an understanding of distance, especially distance and displacement, will help us when we are calculating speed versus velocity. Okay, so let's go ahead and get started. Oh, flip your paper over if you have not. So on the back is where we're going to put this information. So the first thing we're going to do, okay, is do distance. All right. So distance is the total length of the path traveled regardless of the direction. All right. Because we're not focused on direction, distance is a scalar quantity. Will not have direction involved in it. This is what your car odometer reads. So like if you're going 80 kilometers um, per hour, I guess I didn't put that per hour part, which is kind of, it's not that fast. Or you traveled, 73 miles. Okay, that's all distance. It's the total length of the path. We're not focused on the direction you're going. We're not looking at reference points, anything like that. It's just how far you traveled. Any questions about distance? You guys are good? I meant questions. Any questions? Yeah. All right, so now let's look at position. Let's look at position. So position is the location of an object relative to a reference point. Okay, so because we have a reference point, we're going to have a magnitude. We're also going to have direction. Okay, because we have magnitude and direction, we're not looking at a scalar quantity. We're now looking at a vector quantity. An example would be the car's position is 25 kilometers west of the library, where library is your reference point. All right, and our last thing, we're looking at displacement. Now, position impacts displacement, okay? How does that happen? Displacement is the change in position. And so since position is a vector quantity, displacement is as well. An example is the rabbit hopped from 5 meters east of the carrot to 15 meters east of the carrot. Okay, so we're looking at a change in position. The position went from 5 to 15. So the displacement is 10 meters east of the carrot. Are there any questions about distance, position, displacement? All right, so let's look at a little practice with distance versus displacement. All right, so you have this on your handout, and it talks about Xavier traveling to Yvonne, and we're looking at how far does Xavier travel, and what does this value represent? So let's look at that. Um, we're going to use this, all right, to work that out. All right, so Xavier is traveling as we were told, okay, and he's starting here. Okay, he travels 110 meters in this direction here, and then he goes 70 meters here. All right, so we're trying to figure out, well, how far did Xavier travel? So what will we do to find the distance that he traveled? All right, so to find the distance, remember that's the total length traveled, right? So what's the length in this for this part of the journey? So 110 meters. And then what's the total length in this part of the journey? So it's 110 plus 70. Okay? So the total distance that Xavier traveled was 180 meters. Okay? No, go ahead. Because distance is the total length traveled. So because it's total, you're adding all of the lengths together. Okay? It's just like running the basketball court. If we had the length and you had to go up and down the court 4 times, so like let's say it's 50 to make it easy. So that's 50 going that way, 50 coming back, 50, 50, you know, so what is that, 100? So 400 meters is what you would travel. So when we say distance, we're looking at the total. Okay? Well, let's look at the other part. Let's look at the other part of here. It says, what if Xavier was a bird? Okay? How could he get to Yvonne? And what does this represent? Well, do you think the bird is going to go, well, let me go down this street and then go? Yeah, the bird is going to be like quickest way, which is going to be the diagonal here. Okay, that was supposed to be a straight line. Okay, that's supposed to be a straight line right there. It's kind of crooked on my end, but all right. And so then the issue is, what is this value? And we're going to call this x. Okay, unknown is just easy to call it x, right? So how do I find this value? I have a right triangle. All right. How would I find this? If you said the Pythagorean theorem, well, you are correct. Okay. A squared plus b squared equals c squared, where c is the hypotenuse. Okay. It is our x, if you will. So in order to find this, I'm going to take a, I'm just going to call that a, 110 meters. I'm going to square that. Okay. And then I'm going to do 70 meters. I'm going to square that. And that's going to give me c squared. And then, of course, if I need to get rid of the squared, what would I do? How would I get rid of this? The squared. I have to do the opposite operation, right? So what's the opposite of squaring? The square root. There you go. So it's going to be the square root of 110 squared plus 70 squared equals c, which is the distance that Xavier would fly. So what would that be? When you calculate it out, what do you get? All right, so when we work this out, what do we get? All right, we get 130.4 meters. And if we do like a quick little compass here, north, south, let me do it correctly, east and west, this looks like it's going towards the what? All right, so yeah, so it's more like northeast. Now there is a way that we can actually get the degree. It's actually traveling northeast, but that requires doing like tangent. We're not going to do that. So we're just going to go northeast. And how will we show that? What do we have to put? Brackets. There you go. And so brackets northeast. Okay? Y'all just work the displacement problem. I put them on YouTube. All right. Not every single displacement problem requires the Pythagorean theorem. Okay? So let's look at our second set of problems. Or our second problem, I should say, that's on the slideshow. So we have a raceway. All right, and this raceway is designed as a loop, which is basically like an elongated circle, right? One lap is 4 kilometers. So if a race car competes 200 laps, what is the distance traveled? So each lap is 4 kilometers. The race car does 200 of those. What is the distance traveled? 800 kilometers. 200 times 4. Because remember, distance is the total length. So each time the race car goes around a lap, that's 4 kilometers. And if you do it 200 times, that's 800 total kilometers that's traveled. All right. Now, position at the end of the race relative to the starting point. So starting point, we would say that's what? The starting point is distance what? You got to go around the whole thing to get 4. So if you're at the starting point, you're at point 0. Okay? Now, the question is, what is the position at the end of the race relative to the starting point? What that means is we come back to where we started. So if we started at 0, we end at 0. Yeah. So the position is 0 kilometers. All right. Well, if the position is 0 and displacement is the change in position, which is 0, what's displacement? 0 as well. All right. Now, typically, when you have situations where you're going to end up where you started, it's going to be 0. You don't have that problem where you're ending up in a different place, okay, from where you started. But if you end up where you started, then it's always going to be 0. And that's like a cool thing. Not the distance, but the displacement. All right. So let's look at some more practice, okay?